we're going to graph rational functions, find the domain. So y'all are already familiar with graphing functions and finding the domain of functions already. The new thing is you're figuring out how to find a vertical, horizontal, and oblique, or something called slant asymptotes. So I'm going to show you how to do that. What base word do y'all see in rational?
Ration.
What did you say?
I said ration.
You know what? One of my students said that in my first class, but I was not expecting that. Give me, I was not thinking about that particular word, but you are right. Give me another word.
A
Anybody else
fraction?
think huh? What base word do you see in the word rational?
Rat.
Domain.
I don't know.
Okay, I
Oh,
like that. That's new too. I like it. Give me another one. Somebody said something. Give me another one.
Ratio.
Tara. Ratio. I guess next time I need to say math based word. I like it though. Rat is in there. Yeah. Ration is in there. Good. All right. So ratio. Yep. And somebody said it. I don't know who said it, but yeah, basically ratio is just a fraction. It's just a fancy word for you got functions that have fractions now. That's all it's saying. All right. So let's get to it. A rational function is a function that can be expressed in the form f of x equals n of x over d of x, where both n of x and d of x are polynomials. What y'all think n is referring to here and d is referring to? N of x.
numerator.
Numerator, yeah, d. Denominator, right? That's pretty simple. It says where both n of x and d of x are polynomials and d of x is not the zero polynomial. Can you tell me why they're saying that d of x cannot be the zero polynomial?
Because they don't want zero in the denominator.
Very nice. They don't want zero in the denominator. We call that what in math when that happens?
Undefined.
Undefined. Thank you, Monish. All right. Yep, we don't want that to happen. Find the domain of f of x equals 1 over x and discuss the behavior of f near any excluded x values. Yeah, I probably forgot, but you are a little familiar with this function from your parent functions. Recall the reciprocal function. Call the reciprocal function from, uh-oh, is acting up, from the parent functions list. So what we're going to do today is kind of look at these type of functions a little bit more in depth, like how does it get its shape and all that. All right, let's look at it. F of x equals 1 over x. Can you tell me what the domain of this function is? This is like reviewing a little bit. What is the domain of the function? See if we
Would it
remember domain.
would it be from
Okay,
negative?
Mary.
Would it be from negative infinity to positive infinity?
Ooh, no, no. Any other guesses? F of x equals 1 over x. Yeah. All right, let me warn you, final is going to be comprehensive, so I may ask you all types of questions on the final, you guys. All right. How do you find the domain of a function? Did we forget? What do we do?
We
You
did.
set the denominator to zero.
Who said, Alicia, who said that? We did. We forgot it. Thank you, Nakia.
It
Nakia,
was
you
me.
remember.
It was me.
Oh, Raven said that.
Yeah.
Raven said, yep, we did. We forgot that. All right, Nakia, that's good. Now you set the denominator 0. Okay, what does that tell us for this situation? What is the domain then?
It's equal to 0.
Mm-mm. It's not equal to zero. It's
It's
precise.
zero.
That's the number that's precisely not in the domain. Y'all remember it now? All right. That's the number we don't want because if we set x to equal zero, what happens? You told me earlier somebody, Kyria.
Undefined.
Undefined. They will make it undefined. So what's the domain? Remember, I showed
All
y'all
real
three
numbers.
different ways. All real numbers. Okay. Okay. Come on with it. Come on with it. All real numbers.
It's more.
If you gotta be more, because Merrick told us all real numbers earlier. Remember, he said negative infinity and positive infinity. That's the same thing. It's all real numbers. All real numbers. No, it gotta be something else. I won't. All right, we forgot. Except, we forgot x equals zero. It's
Except
all
zero.
real numbers except, yeah, x equals zero. Or another way we could write it: negative infinity to zero, parenthesis, union, 0 to infinity. Or what's that notation called? As a reminder, what is that called? What type of notation is that?
Union.
Mm-mm.
Oh, interval notation.
Interval notation. Woo! Yeah, we need a break. Or all right, and y'all remember something like this with the braces: x such that x
Yeah,
cannot
this
equal
is standard
zero. What is that called?
standard notation.
Set builder. Set builder. That's set builder notation. And yep, this is called interval notation. We needed that review. Let's see if we remember how to graph. I don't know. I don't know. Let's see. So we're going to graph this function f of x equals 1 over x. We already know what's going to happen at 0 again. If we plug in 0, what's going to happen? We call it what? If we plug in 0. The Kyria help us out. If we plug in 0, we get what?
Where it crosses the x-axis.
Maybe Alicia remembers. Alicia, what happens if we plug in 0 to this function?
You're gonna get 0.
It gets 0.
No, y'all. If we plug in 0 right here,
Oh, you get
It's undefined.
Undefined.
undefined. Undefined. Remember? All right. Okay. 0 under the line is undefined, y'all. Y'all gotta remember that. 0 under the line is undefined. Now, if it was up the opposite way, if 0 was in the numerator divided by a number, then it would have been 0. So we're gonna to showcase that, I'm gonna put a dashed line right here at 0, x equals 0. So this is x equals 0. Remember, when we do vertical lines, we put x equals the constant. All right, so I want to show you what happens around that line. We're gonna approach this function we're gonna approach the 0. Well, let's just say this. We're going to approach this line right here from the left. So, for example, we're going to go this direction from the left. So, this is from the left here. Then we're going to turn around later and approach it from the right. All right, I'm going to erase this, but I'm just letting you know which direction we're going in. So, first, let's approach it from the left. So, we're going to plug in a number like -5 and see what happens. So we plug in -5 into this function right here. What do we get?
-1/5.
Very
One
nice.
fifth.
-1.
Neg-
Yep, -1/5. What is that as a decimal? Because we're trying to graph it. So what is that? What is
0.5.
-1/5 really?
Negative 0.2.
Nice. All right. So I'm gonna go ahead and plot it. All right, in another color. Let's see. Let's go with purple. That's my favorite color, y'all. Purple. All right. So -5, -0.2. We're gonna say it's right here. All right. Let's plug in. I'm gonna skip something. -3. Let's plug in -3. Where do you get when you plug in -3?
-1/3.
Yep. And what is that really? Negative what?
0.3.
0.3.
All right. It doesn't it keep going.
Yes, ma'am.
We're gonna put a little line over that says it repeats. All right, so -3, I'm gonna go ahead and plot that. Negative, I don't know, right here. I'm gonna skip again. Let's go to -1. We plug in -1, what do we get?
-1.
Very nice. -1. So -1, -1 right here. I want to get even closer to 0. What would you plug in if I want to get even closer? Y'all see what's happening? Y'all see how it's curving like this? If I want to get closer to it, because I want to see if it's crossing it. What were you? Give me
Over
something
1.
closer. We did -1. It was -1,
So
right?
a +1.
I'm approaching it from the left, so I don't want to cross it.
A 0. No.
I can't plug in 0. What happens? Undefined. I know y'all trying to avoid a fraction. I know it. I know it. I know it. I know it. But we're gonna plug in -1/2 where you like whether you like it or not. And I'm gonna make you figure out what is 1 divided by -1/2. All right. All right, come with it, Math 112. 1 divided by -1/2. Impress me. What is that equal to? What does that equal to?
2.
1 divided by,
-2.
ooh, -2. Very nice. Very nice. -2. Because 1 divided by -1/2 is the same thing as 1 divided by -1/2. Y'all know. Keep change flip. Keep change flip. That's going to give you -2. All right. So -1/2 is about right there. See, so what's happening is this. Y'all see how it's curving right here? Notice it's never going to cross that vertical line right there. We said it was undefined, remember, at 0. So we're not going to cross it because our domain is not there. It's not allowed there. All right, let's approach from the right now. We're going this direction now. I'm going to skip some things because we kind of can glean some information off what we just did. So let's try 4. If you plug in 4, what do you get in
1
this
over
function?
4.
1/4, which is what really?
0.25.
Nice. So I'm going to go ahead and plot that for, and guesstimate is about right here. All right, let's skip again. What about 2? Plug in 2.
1 over
1/2.
2.
1/2, what is that really?
0.5.
0.5.
Yep. So 2, 1/2. And y'all kind of see what's about to happen. Let's plug in 1. What do we get?
1.
1. What about 1/2? Make y'all do it again.
2.
Very nice. All right. So y'all see on this side, maybe this refresh your memory. Remember these one of the parent functions that I asked you to remember so long ago. All right, so you may have forgotten. So here's a little note in the box. Note that as x approaches 0 from the left over here, y'all see that f of x decreases. See how this line is going down? It decreases without bound. It's going to -infinity on this side. And then it says, in contrast, as x approaches 0 from the right over here, f of x increases. Where is it going? On the right side. To where? All right, on the left. Let me say it
What?
again. On the left. Going to -infinity. As we approach from the right, it's going to positive
Positive
infinity.
infinity.
Yes, positive infinity. All right. Here are some more examples of parent functions. Not parent functions, rational functions. Y equals 1 over x minus 2. Let me quiz you again. If I ask you right now, what is the domain of y equals 1 over x minus 2? What would you say? What is the domain? Because we forgot about domain. We kind of buried it. We said we're not gonna deal with that anymore. No, it's gonna pop back up, y'all. We gotta remember it. What is the domain of y equals 1 over x minus 2? Anybody?
Plus 2.
Huh? Say it again, again.
Plus 2. Like when you set it to 0, it'll
You
just be
said set it
2.
to 0. So what's this domain then? What is the domain then?
It'll be negative infinity to
2.
2.
To 2, okay. And
Then the union, then 2 to positive infinity.
so the domain is what two the domain is what this function is allowed to, what x values this function is allowed to be. 2 is what it's not, okay? So it's everything but 2. That's what I'm trying to see. Y'all got to reverse. Y'all get the answer and y'all say, that's the domain. Nope, that's precisely what's not the domain. That's precisely the number we're throwing out of the domain. All right, every other number is in the domain. All right, let's graph this function. All right, I'm going to skip that. Just those are some more examples of rational functions. All right, find the domain. So again, she just told us negative infinity to 2, parenthesis, union, 2 to infinity. Or you write all real numbers except x equals 2. Or you could write braces x such that x cannot equal 2. All right, let's try this again. If we plugged in 2 into this function, what would we get?
Undefined.
Undefined.
Thank you, undefined. So what I'm going to do is put a dashed line in x equals 2 right here. All right, because our graph, believe it or not, is not going to cross it. It's undefined there. All right, we're going to approach it from the left again. If you approach it from the left, let's plug in some numbers like, let's go with -2. If you plug in -2 into this new function right here, tell me what do we get? Anybody?
Into the 1 over x minus 2.
Correct.
0.
-2. -2. 2. If we plug in 2, we get undefined. Let's plug in
Oh,
-2.
negative 1/4.
-1/4. Which is what really? What is that? Negative.
Negative 0.25.
Correct. So let's go ahead and plot it. That's -2, -0.25 right here. Let's plug in 0. What do you get when you plug in 0?
Negative 1/2.
-1/2. All right, what is that? Negative
Point 5.
0.5. So at 0, we're going to do here. Let's get closer. We're approaching from the left right now. Plug in 1. What do we get?
Negative 1/3.
Sure. Positive. Let's do +1. Let's do +1.
-1.
-1? Yeah, because it'll be -1 over -1. All right. Let's get even closer. I know y'all don't like it, but let's do 1.5. Let's plug in 1.5 or 1.5 or 3/2, however you want to say it. Plug in 1.5, what do we get?
-2.
-2? Okay, thank you. 1.5. So y'all see it's doing the same thing it did before. All right. Try it again. Let's approach from the right side. Let's plug in, I'm going to skip. Let's just do 4. Plug in 4 into this function. What do we get?
0.5.
2. 1/2.
1 over 2, which is
0.5.
0.5. So 4, 1/2. Because we kind of know what's about to happen. So let's plug in 3. What do we get?
One.
1.
1.
Y'all see what's happening? It's gonna do this. So we're gonna stop there. It's gonna do that. Isn't that basically almost the same thing as this one? What's the
Yes.
only difference? Only difference between the two graphs.
On the second graph, x was 2.
Well, the vertical asymptote, well, we're gonna get to that. Well, the forbidden little space is at x equals 2. Over here is x equals 0. Y'all see, this right here is really just a horizontal shift to the right 2 units. I know y'all probably forgot those too. Transformations, what? We still doing that? Yep. All right, it popped back up. All this is it shifted to the right 2 units. That's all it did. It's the same function shifted to the right. All right, we're gonna move on. Let's talk about what the meat and potatoes are for this section. Asymptotes. There are 3, but let's cover 2 for the next 15 minutes. That's vertical and horizontal asymptotes. Below shows the vertical and horizontal asymptotes of the graphs of 3 rational functions. I'm going to go ahead and tell you, these are examples of vertical asymptotes that we just did. X equals 2 was a vertical asymptote, and I'm going to show you how to get it. And then x equals 0 was a vertical asymptote. So a vertical asymptote is basically a vertical line that your graph would never cross. All right, it's a vertical line. Maybe I should write that. The graph will never cross a vertical asymptote.
So is that pretty much where the graph is undefined?
Yep, that's why. And that's why precisely, Mary. Very nice observation. That's precisely why it won't cross it because that's where it's also undefined. Very good. Very good. All right. Now, most of the time, it won't cross a horizontal asymptote either, but sometimes it crosses the horizontal asymptote. Sometimes it crosses the horizontal asymptote. It's rare, but sometimes it does. But it never crosses the vertical asymptote because, like Mary said, it's kind of like where it's undefined. So that is out of the question. It crosses the horizontal asymptote. All right. Look at these 3 examples. We have this function here, 2x plus 1 over x plus 1. Notice that the vertical asymptote is x equals -1. Looks like it has something to do with denominator. Okay, just throwing that out there. Maybe. All right, then the horizontal asymptote is y equals 2. Maybe it has something to do with this coefficient right here. All right, let's look at the one in the middle. 4 over x squared plus 1. Notice that there's a horizontal asymptote, but there's no vertical asymptote, and I'm going to tell you why. And then on the right here, we have a vertical asymptote at x equals 1. So they're showing you the dashed line here. But notice, I'm noticing now that when the horizontal asymptote is the x-axis, they don't put a dashed line, okay, for whatever reason. All right, so here we go. Vertical and horizontal asymptote, and I'm going to probably write this in my own words. Where n of x and d of x have no common factor. So we have a rational function. The graph of f has vertical asymptotes at the zeros of d of x. All right, I'm going to write this in my own little way. Here's how you find it. Okay, write this little note for vertical asymptotes, and we're going to call it v dot a dot for vertical. We're going to shorten it to VA. All right. After canceling common factors, set the denominator to 0 and solve for x. That's how we're going to find the vertical asymptotes. All right. Again, after canceling common factors, because it says it can't have any common factors. That's why I said that. So after canceling common factors, set the denominator to 0 and solve for x. So let's go back and look at these examples. For this first example up here, function is 2x plus 1 over x plus 1. That's not factorable. It doesn't have any common factors. So we go straight to setting the denominator to 0. So what's the denominator for this function?
X plus 1.
Yep, we would just set x plus 1 equals 0 and solve for x. Y'all see that we end up getting x equals -1 for the vertical
Mhm.
asymptote? All right. Any questions about that one? All right. Let's go to the middle function over here. 4 over x squared plus 1. All right. What happens? Okay, there are no common factors, so we go straight to the denominator. We're going to set x squared plus 1 equals 0. What happens that's a little weird here?
You got the x squared.
X squared. What are we doing after that? We do what to solve for x?
It's
Tell me how to solve for x.
you subtract x from each side. Then you
Not subtract x. Subtract what? You
I
just
mean
said the wrong
one.
line.
I'm sorry.
Uh-huh.
Subtract one from
Uh-huh.
each side.
Subtract 1.
And
But
what?
a
But
negative is gonna be under the radical.
yeah, we got those eyes. Y'all
Right.
remember we got eyes. So when you get eyes, we don't have asymptotes. All right. So that's why they didn't give you a vertical asymptote here. All right. We're gonna move to the one on the right. All right. This one. 2 over x minus 1 squared. What's the denominator again?
X minus
X
one
minus
squared.
1 squared.
X, yep, x minus 1 squared equals 0, which is really x minus 1 times x minus 1. Okay, it's the same thing. So x minus 1 equals 0. Y'all see why the vertical asymptote is x equals 1. All right,
Yes, ma'am.
so that's how you find the vertical asymptote before we move on to horizontal asymptote. All right, if you can factor and cancel common factors, you must do that first for vertical asymptotes. That's the only difference, honestly. I don't know, Merrick, that's the only difference between domain and vertical asymptote, really. Domain, we don't cancel and cancel out things first. We just set the denominator 0. Vertical asymptote, we cancel out common factors first, and then we use what's left over. All right, let's talk about horizontal asymptote, how we find that. It's more involved, as you can see. What we're going to do is compare degrees of n of x and d of x. What is n of x again? That's why I asked you all earlier. What do you think
Numerator.
n of x is referring to?
The numerator.
Numerator, and d of x,
Denominator.
denominator. So we're going to compare the degrees of the numerator denominator. Now, if the degree, and this is what n stands for, degree of numerator is less than the degree of denominator, then the horizontal asymptote is simply y equals 0. We don't have to even work anything out for that one. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equals 0, or in other words, it's the x-axis. All right. If the degrees are equal to each other, then it's the ratio of the leading coefficients, and I'll explain that. And if the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. All right. So if you don't have your notes printed out, just take a snapshot. Take a picture of this really quickly because I'm gonna go right back up to those examples again to look at what they said was the horizontal asymptote and compare it to these notes here. All right. Here we go. Did we take a snapshot? All right, here we go. Let's go up here. The first one, 2x plus 1 over x plus 1. What is the degree of the numerator?
1.
1, all right, because it's 2x to the 1 power. All right, degree of the denominator?
1.
1. Aren't they equal to each other?
Yes, ma'am.
All right, good. So we're going to go with B. When they are equal to each other, it's going to be y equals a sub n over b sub m. What is that? Just the leading coefficients. That's all. So let's look at it. Let's look at it. So our horizontal asymptote, let's call it h dot a dot, is y equals, what's the leading coefficient of the numerator?
2.
Yep. Divided by, what's the leading coefficient of the denominator?
1.
1.
1, which is why our horizontal asymptote is y equals 2. There it goes. That's where they get that from. And you see the little dashed line right here. Y at y equals 2 is a horizontal line. That's why you have to put y in front of the number. Y equals the number. I'm going to be hard on y'all with that. Vertical lines, you're going to put x equals a constant. And horizontal lines, you're going to represent horizontal lines by y equals a constant. All right, let's look at this one. We're only talking about horizontal for these last examples. All right, here's a tricky one. Let's see if y'all remember. What is the degree of the numerator here?
0.
Very good. Well, look here. Look here, remember, it's 0. It's definitely not 1 because we don't see x to the first power, right? We don't see x. So it is 0. So 0 in the numerator. What about the denominator? What is the degree of the denominator?
2.
2. Is it 0 less than 2? All right. So degree of the numerator is less than the degree of the denominator. Then our horizontal asymptote is
Y equals 0.
y equals 0. Automatically, y equals 0. You don't even have to work anything out with that one. All right. Any questions so far about horizontal asymptote? All right. Let's do one more, and then we'll practice. We have 2 over x minus 1 squared. What's the degree of the numerator?
0.
0.
0. Degree of the denominator?
1.
0.
No. All right.
2.
2, right? Because if you work this out, it would be x squared. X minus 1 times x minus 1. X squared minus 2x plus 1, right? So definitely 2. So again, the degree of the numerator is less than the degree of the denominator. And that's A. Horizontal asymptote is y equals 0 or the x-axis. All right. All right, let's practice. I'm moving things around. All right. Find all vertical and horizontal asymptotes of the graph of each rational function. Let's look at A. All right. How do you find a vertical asymptote? Remind me again. How do we find a vertical asymptote?
Set
Look at
the
Uh,
denominator to 0.
Yep. Now notice that we don't have any. We have something that's factorable, but it's not going to cancel. Well, 2x squared. So we're going to go ahead and just go straight to setting x squared minus 1 equals 0. What would you do next to solve for x?
Minus one on both sides. I mean, plus one on both sides.
All right. All right. I want y'all to finish. So I'm going to give you 30 seconds to finish and tell me what what's the solution.
X equals 1.
X equals
So,
plus or minus one.
all right, plus or minus 1. So that's why I asked you all to finish it because I wanted to see if you would forget that there are actually two solutions, right? That's why I would rather y'all factor. X plus 1 times x minus 1 equals 0. If you tend to forget that there are two solutions for this one, I want you to factor. All right. So our vertical asymptotes, actually there are two this time. They are x equals -1, x equals +1. All right. Let's go to horizontal asymptote.
Dr. Thomas, I have a question.
Yes, yes, yes.
Say it was not 1, it was like
Hmm.
25, and you could actually get the square root. Would it still be plus or minus 5?
Yep,
Okay.
because you can factor. That's still a difference of squares, x plus 5, x minus 5. All right, horizontal asymptote. What are we comparing again when we trying to figure out the horizontal asymptote? What are we
The
comparing?
numerator and the
The degree.
denominator.
What about the numerator and the
The
denominator?
The
degree.
degree.
The
The degree.
degree, the degrees. So what's the degree of the numerator for A?
2.
Two.
2. Degree of the denominator?
2.
Two.
2. Okay. They are the same. So what does it say? It says when they're the same, we're going to do the ratio of the leading coefficients. So make sure you always put y, though. All right. What's the leading coefficient of the numerator here?
2.
Yep. Uh, leading coefficient of the denominator?
1.
1.
All right. Therefore, our horizontal asymptote is y equals 2. All right. And here's the graph on the right. I didn't point it out because I wanted you to see that y'all notice they have two vertical dashed lines that represent the asymptotes, vertical asymptotes, and then they have that horizontal line over here. That's your horizontal asymptote. All right. And they graphed it. To graph the black part, of course, you have to use a t-table like we did earlier to figure out what's going on in all the other sections of this graph. All right, we're not gonna go back over that. I, we can graph now. I just wanted to make sure we know how to find the vertical and horizontal asymptotes because in this section and for the homework, that's what they're gonna ask you. All right, B, x squared plus x minus 2 over x squared minus x minus 6. All right, what should we do first for this one?
Factor.
Factor. Yep, exactly. All right, so we have f of x equals, tell me what are the factors for x squared plus x minus 2?
X plus 2.
X plus
X minus 2.
X minus 2. No, I'm
All
sorry.
right,
X
you
plus
you
X.
you said x plus 2, x minus 1.
1, yeah.
All right, over, what about x squared minus x minus 6?
X plus 3x minus 2.
X. All right, when you multiply, do you get x squared minus x minus 6?
Is x minus 3 x plus?
Yes, x plus 2. Notice we have common factors. Bam, bam. All right, so really what we got to work with is x minus 1 over x minus 3. All right, this is what we're working with right here. All right, so our vertical asymptote, we're just going to set, not the original. For vertical asymptote, we're going to set, I don't know why it's not acting right. x minus 3 to 0. And what do you get when you set x minus 3 to
3.
0?
3.
X equals 3.
How I want you to say it, though. How I want you to say
Y equals
X
3.
equals
it. X
Um,
equals 3.
X
So
equals 3.
for vertical lines, it's always x equals a number. All right. Horizontal, all right. I don't think it matters if you look at the original or if you look at the this. All right. If you compare the degrees, what can you tell me about the degree of the numerator and the degree of the denominator?
they're the same.
They're the same.
They're the
Same.
same. Therefore, we have y equals leading coefficient of the numerator is
1.
1,
leading leading coefficient of the denominator is.
1.
1.
Therefore, our horizontal asymptote is y equals 1. All right. Here's an extra tip. All right. There is a hole in the graph when there are common factors, like what just happened. All right. So there are holes in the graph. Now, what was the common factor? What was the common factor for this situation?
X plus
X
2.
X
equals
plus
2.
2.
Yeah, we're going to set x plus 2 equals 0. And here's how we find out where the hole is. We set x plus 2 equals 0. We get x equals negative 2. We're going to find the point where is a problem. Then what we'll do is plug in negative 2 into this part right here. All right, plug in negative 2 for x. So negative 2 minus 1. And this is extra. If you know this, it kind of helps you out. All right, negative 2 minus 1 over negative 2 minus 3. All right. What's negative 2 minus 1?
Negative 3.
Negative 3.
Negative 3 over negative 2 minus 3.
Negative.
Negative 5.
Yep, which is 3/5. So all I'm saying is there's going to be a hole at the point. All right, continue. Hole at the point negative 2 3/5. And we're gonna use Desmos. It's gonna be the last thing that we do today. Let's go to Desmos and graph this original function. Mm, all right, let me encourage you all to do really well on your quiz. Raven, like I was saying earlier, you do good on things like that because you only have 5 quizzes in all. Um, so it's gonna have a more of an impact than homework. Homework, you're probably gonna have like 15 or 16 homework sections. So it balances itself out pretty nicely for homework. So it's not gonna make a big impact if you're already doing well on homework and you continue to do well. It's not gonna make a big impact. What's gonna make a big impact is if you weren't doing so well on some in a quizzes or a test and you do significantly better. That's gonna make the biggest impact. All right, let me show y'all this. I know that Desmos does not show you the dash line. I wish I could write on Desmos, but I can't. I don't think I can. If y'all know I can, let me know how to do that. But you do see, y'all see like a little space. What's the vertical asymptote for this function again?
3 over 5.
What's the vertical asymptote? Let's go to that
Plus
first.
I
3.
think
Now,
it's 3.
how do I want you to say
X equals 3.
it?
Y.
X
X
equals
X
equals
3.
equals
3.
3.
X equals 3 for vertical asymptote. So notice, y'all see you notice it's never going to cross x equals 3. It's this imaginary vertical line that it will never cross. This is 3 right here. on the x-axis. It's never going to cross this x equals 3. All right. And what's the horizontal asymptote?
1.
How
Y
I want
equals
you to
1.
say it, Nikki. Y equals
Y
1.
equals 1.
So, yeah. Notice for this one, it doesn't look like it's going to cross y equals 1. If you try to make it small, it looks like it's never going to cross. Sometimes it actually crosses the horizontal asymptotes. This one doesn't. It doesn't look like it. Now I'm going to show you where the hole is. I know you're not going to see it, but I kind of played with it earlier. We said it was at, let me see. What did we say? 3 something.
-2 and
Oh, -2 and 3/5. So this is what I'm going to do on Desmos. -2. I'm going to go to x equals -2. Okay, come on, work with me. All right. -2. I'm going to try to find -2 with my mouse. -2. Come on, -2. What happened at -2? Y'all see it? What does it say? -2?
Undefined.
Undefined. That's the point, -2 3/5. There's a hole right there. And as you can see, that's the hole. There's a hole in the graph. All right. And you find that by setting that common factor to 0, plugging that into your reduced fraction rational function. And that'll tell you where the hole is in the graph. So there's an extra little tip to figure out what graph is the right graph. If you know where the hole is, you can kind of figure out which graph is the correct graph on your homework assignment. We will continue this lesson next week. We have one more asymptote. We're going to call it the slant asymptote. It's also known as the oblique asymptote, but I probably refer to it as slant most of the time. That asymptote is actually slanted. It's not vertical. It's not horizontal. It's slanted. All right. And I'll show you how to do that. All right, you guys. That's it for today's lesson. If